problem is about alternate medicine use. And this is another one where they compare something from several years ago, 1991. So here's the 1991 study. And they had 1,539 adults participate in this study. And 500 of them, 520, said that they had used alternative medicines, folk remedies, homeopathy in the previous year. All right, so we can actually go ahead and calculate p hat from that by taking x and dividing by n, just to get a sense. And so our p hat is about 0.338, I'll call it. 33.8%, about a third, just over a third, back in 1991, used alternative medicines. All right, since this is back then, I'm going to give all of these the subscripts of 1. This will be our first set of summary statistics and our first population. Okay, then in a recent study, let's say, 2019 or more recently, we have N2 is 2,055 adults, and X2, of those in the recent year, 865, said that they had used alternative medicines in some format or another. So we can compare the sample proportion this year, or 2019. So 865 and divided by 2055. All right, this one's a little higher, 0.42, I'll round it to 1. So it appears just from our sample results that there's a higher percentage, we'll call this 34 to 42, about 8 percentage points higher in the current year of those who use alternative medicine versus the previous year. So these are the summary statistics. And now we have to decide, as statisticians, we need to decide whether this difference that we observe, this 8 percentage point difference, is it statistically significant? And so we're either going to say there's evidence to suggest, based on the claim, has not changed, has not changed. So it looks like it's changed, but is this difference that we observe is it statistically significant? Is it gonna lead us to conclude that, yes, in fact, the views have changed over that, well, it's almost a 30-year period. Okay, so go through the 5 steps. Start with the hypotheses. Remember that for this particular test, the null hypothesis is always the same. P1 equals P2, but be sure that you define the meaning of the variables that you use. And the variables in this case are population proportions. The population proportion in the 1991 study, we'll call that P1, and the population proportion in the current study is P2. And then level of significance. That's going to be always step 2. So have to say what alpha is equal to. And then 3, for step 3, is always to gather the evidence. So you put all this in here and calculate a test statistic. And to calculate that test statistic, we're going to use this new function. We're comparing 2 proportions. They have big enough sample sizes, so therefore the difference in the 2 population proportion, the difference in the sample proportions will be a z distribution. And we want the test statistic and p-value, and we get that from the 2-prop z test. It's going to ask for x1, n1, x2, n2, and then it's always going to ask for the alternative hypothesis. So P1, and then you have to decide if it's not equal to P2, less than P2, or greater than P2. And then circle one of those. And this will calculate a z test statistic and the p-value. So you want to write those. And number 4 is to make the decision. And remember that if p is less than alpha, we reject the null hypothesis. So is it that one? Or if p is greater than alpha, do not reject. Is it this one? Well, you'll find that as soon as you calculate your p here. And then finally, the conclusion. There is evidence to support the claim. There's not enough evidence to support the claim. There's evidence to reject the claim. There's not enough evidence to reject the claim. It just depends on where the claim is and how you set up the test. Okay, so fill in the details. It says, can you reject the claim that the proportion of adults using alternative medicines has not changed since 1991? So the way that we're going to reason this through, has not changed since 1991, means that the proportion today is the same as it was back in 1991. So the percentage back in 1991 that used alternative medicines is the same as the percentage that use medicines in a current year. So remains the same means that the proportion back then is equal to proportion today. So this proportion back then in 1991 is the same as in a current year. And so here's your claim. And they didn't indicate if there was a change, if there would be a higher use of alternative medicines these days, or not as much alternative medicine use these days. They didn't indicate one way or the other, so we want the not equal to there. And P1 equals the population proportion of adults using alternative medicines in 1991. And then P2 would be the proportion, and all the same language except in the more recent year, we'll say 2019. Okay, so we have both hypotheses written. They're written with population parameters. They're competing hypotheses. The claim is the null, and we've defined the 2 variables that we use in the hypothesis. Move on to step 2, alpha 0.05. And then we get the calculator out and calculate the test statistic and the p-value with our hypothesis test. So x1 is the 520 and n1 is the 1539. Just make sure you get those in the right spot. Over here, x2 is equal to 865 and n2 is 2055. And then the alternative hypothesis is the not equal to. So we're going to select that one. All right, option number 6 on your calculator, 2-prop z-test. 520, 1539, 865, and 2055, not equal to, and then we will calculate. Okay, so first thing it reports is the alternative hypothesis. Confirm that you know that you were calculating the p-value for a two-tailed test instead of a one-tailed test. We see this z-score, this test statistic, that's -5. That means this difference would be 5 standard deviations away from the mean of the sampling distribution, and that's a very, very unusual sample indeed. Here's another one where we said be sure that you read the p-value from right to left, because the p-value is not 4.16. It can't be. It has to be a probability value between 0 and 1. It reports out the p1, 0.338. There's our 0.338. And the other one that it reports out is p2, which is the 0.421. Okay, there it is. And then they give you this pooled proportion. And the pooled proportion, just so you know how to calculate that, it's going to be somewhere between P1 and P2. The sample sizes are different, so it's not going to be immediately in the middle. But the P hat, which is called the pooled proportion, we're going to take both of the X's and add them together. And we're going to take both of the sample sizes and add them together. And if you do that, you will get this 0.385 number. And this pooled proportion is one of the statistics that we would use to import into the test statistic formula if we were actually using it. But you can see it's somewhere between these two numbers. All right, I'm going to write out the test statistic. -5.06, we'll call it 2, and the p-value is E-7. So this number, 4.16, 30154, E-7, means that you have to take that decimal point and move it 7 places to the left. So 0.1, 2, 3, 4, 5, 6, 4, 1, 8, something like that. Anyways, there's very little area beyond 5 standard deviations less than the mean, and that's why that's such a small p-value. Okay, so if we compare our p-value of 0.00004 to our alpha value, which is 0.05, you can see that our p-value is less than the alpha value. And if that happens, our decision is to reject or null hypothesis. All right, so p is less than alpha, reject. And the conclusion, in this case, it's going to be a little bit different because we are rejecting the claim. And the claim is that P1 is equal to P2. Now let's go backwards. That the two proportions are the same. We're rejecting that the two proportions are the same. So we're rejecting that the proportions stay the same. So we're rejecting the claim that the proportions have not changed. Or, yeah, has not changed. So we're going to reject this. And we actually show support for an alternative hypothesis that wasn't our claim. So we have rejected the claim that the proportion has not changed. So that's how we're going to write it up. There is evidence to reject the claim. That the percentage, and I guess we're talking about of adults, has not changed. Since 1991. Okay. This is kind of a weak conclusion because I didn't say anything about, you know, what the percentage was. And so if I were to want to provide a little bit more detail right after adults here, I would say the percentage of adults that have used alternative medicines has not changed since 1991. So there's the first. Now, while we're here, I think I'd like to go ahead and calculate the confidence interval. And just to give you another example of calculating the confidence interval in this context. So here is the summary sheet that I gave you last time. So I'm going to refer to that. It's part of the lecture notes from last time. So the calculator function that we want is 2prop z int. The numbers that we enter in here are exactly the same. So they're going to ask us for x1 and n1 and x2 and n2. And there's no alternative hypothesis for a confidence interval, but what they will want is the confidence level. All right. Now, since alpha was 0.05, it's always the case that alpha is equal to 1 minus the sea level. So it has to be the case that the sea level must be 0.95 to be consistent with the alpha of 0.05. So 0.95 is what we want. And let's go ahead and calculate that. Remember, we're looking for an interval, a confidence interval that gives us a lower and an upper bound. And this is to estimate the difference in the two proportions. The proportion from 1991 minus the proportion from a current year. Stat, tests, there's the 2prop z test. Remember, you want something with interval or int next to it. So find the 2prop z int. There. All the numbers should still be in there. There they are. The only thing we have to change is the sea level, 0.95, and then we're going to calculate. Now, the actual numbers here are not what's important, but I will enter them in here, negative 0.1149 and negative 0.0512. All you need to know is that this lower bound is negative and the upper bound is negative. Negative, negative. So it kind of looks like this interval where you have a negative number there and a negative. So negative and negative. And since we're estimating P1 minus P2 here, then what we're saying is P1 minus P2, since the entire interval is negative, and this is what we're estimating, the entire interval is negative, so therefore P1 minus P2 is less than 0. That's negative. And then if you add P2 to both sides, you get P1 is less than P2. So what we're saying here is, we're 95% confident that the difference in the proportions is negative, or we're 90% confident that P1 is less than P2, or we're 95% confident that the percentage of adults in the US has increased over the last 30-year period. The proportion that use alternative medicines has increased over the last 30-year period. All right, so that would be a confidence interval. They don't ask ask for that here, but if you have the null hypothesis is P1 equals P2, the evidence that we found using the confidence interval is that P1 is less than P2. And if that's the case, then we show support for H1. So if we use the confidence interval to make the decision, we would say that, oh, there's evidence to support H1 and no evidence to support H0. And that's why we crossed out H0, and there's support for H1.